Hello everyone, welcome to Electronics Hub. In this video we will see how to generate a sine wave on 8051 microcontroller. So as always we are using keil for programming and proteus for simulation. So let's start with the program. So this is our program. In the start I have included reg51.h file, and in main firstly I have declared an array of 16 elements. So how to find the values for these 16 elements? We are creating our sine wave on a port, let's say port 1. So minimum value on port 1 is 0 and maximum is FF, that is 255. So V peak to peak is 255. Now middle element is 127.5. As we have to give integer value, we will start with 127. So our sine wave will start from 127 and it will end just an element before 127, so that we will repeat these elements in a while loop and we will get our continuous sine wave. So how to find all these values? Let's say x of I equal to 127, which is mean value, plus 127 into sine of 360 into I divided by n. So what is n? N is total number of elements in one loop. So for here n is 16 and I will run from 1 to 16 or 0 to 15. So for different values of I we will get different values of x. So this is base value, this is amplitude, and this is for sine wave. So for n values we will get n samples, and by repeating these n samples in while one loop we will get our sine wave. So I have calculated these values on calculator and I have written them here. You can also use math.h file, but you have to include it over here. Then simply I have just assigned the value of x of I to port 1 and repeated the process again and again using while one loop. Now I will build the project, and now I will go to debug mode. I will go to setup. So port 1 is already included. Now I will run it. So here we are getting our sine wave. Let's check the frequency. Okay, so current frequency is 7.5 K. Now if you want to change the frequency, then you can add delay over here. And for changing frequency or improving the quality or smoothness of sine wave, you can increase number of elements in the sine wave. Now we will move to proteus. So this is first part. Our sine wave is available on 8 inputs. So we are converting the 8 input digital signal into an analog signal. For this we have used weighted register DAC. You can find the link for learning weighted register DAC in description of this video. Now you can see that I have loaded the hex file. Now I'll run. I will pause, stop, and here is the sine wave available. Now if you want a smoother sine wave, then you can use a low pass filter over here so that higher frequencies will be eliminated. You can use R2R ladder as well, as shown here. Like this. So that's it from this video. The program files and simulation files will be available through description. You can download them and check the output. And if you have any comments, then please tell us in comment section. And if you like the video, then hit the subscribe button. Thank you.